In this video, we're going to go over the steps for drawing Lewis structures. All a Lewis structure is a way to see how the electrons are being shared within a covalent molecule. The electrons are either represented by dots to represent lone pairs of electrons or lines to represent shared pairs of electrons. I've broken the process down into 5 easy steps. Let's work through an example for SO3, which is named sulfur trioxide. So the first step of drawing a Lewis structure is going to be to find the total number of valence electrons. So in our compound, we have sulfur and oxygen. So we need to know how many valence electrons those elements have. So remember that the valence electrons depends on what group they're in. So we count from left to right. Oxygen and sulfur are both right here, which means we have 1, 2, 3, 4, 5, 6 valence electrons in one sulfur atom and one oxygen atom. But you can see in our chemical formula, we don't just have one of each. We actually have 1 sulfur and 3 oxygens. So each one of those atoms has 6 valence electrons. So if we're going to figure out our total amount, it's going to look something like this. 1 sulfur atom has 6, and we only have 1 of those. 1 oxygen atom has 6, and we actually have 3 of those. So we have 6 plus 6 times 3, which is 18, gives us a total of 24 valence electrons. Step 2 is going to be draw a skeleton structure. So a skeleton structure means we're going to lay out all of the atoms that we have and start off by drawing just our shared electrons. So we're usually going to take whatever atom comes first, and it's going to go in the middle. And then we're going to take whatever atoms we have after that and place them around the outside. The location doesn't really matter right now, just somewhere around the outside. One really important note is that hydrogen will always go on the outside. Doesn't matter if it's listed first or not. Hydrogen always goes on the outside. So remember that we have 24 valence electrons. So I'm going to pull those over here. So remember that these are all the electrons that we have that we can use in this structure. What you'll see is that instead of 24 lonely electrons, I actually split them up into 12 pairs of electrons. That's because in our Lewis structures, our electrons are always going to be in pairs. So to finish off our skeleton structure, we're going to start off with 2 shared electrons between the outer atoms and the central atom. So that means between this sulfur and this oxygen, we need to have 2 shared electrons. And between this one and between this one. So you can see that would be our finished skeleton structure for step 2. Step 3 is going to be to place the remaining electrons around the atoms, starting on the outside. And also, don't ever give one atom more than 8 electrons. So remember, these are all the electrons we have left. So I'm going to start arranging them around the atoms, starting on the outside first. So I'll start over here. Okay, I'm not going to put any more on that oxygen because as you can see, there are already 2, 4, 6, 8 electrons touching that oxygen. So at this point, I need to make sure I've used all of my electrons. Remember, we started out with 24, and I've used all 24 of those. We can't add any more than 24, and we need to make sure we've used all of them. So step 4 is going to be make sure all atoms have a complete octet. If not, move electrons around to form double or triple bonds. So let's check. So we moved all of these electrons around our oxygens and said that all of our oxygens have 8. Now we need to check on our sulfur atoms, because remember, all of the atoms have to have an octet. So right now, sulfur has 2, 4, 6 electrons that are being shared with it. that's not 8 yet. So sulfur does not have an octet. So what we need to do is move electrons around to form double or triple bonds to make sulfur happy. What we can't do is just add 2 more electrons, because remember, we only have 24, so we've already used them all. We can't pull in any more. What we can do is use the ones that we have. So I'm just going to pick one of these oxygens. I'll use this one, and this oxygen is going to share 2 more of its electrons with sulfur. So now this oxygen still has 2, 4, 6, 8, but now sulfur also has 2, 4, 6, 8 valence electrons. Our last step is just to draw the final structure. So let me show you how this ends up looking. So each a pair of electrons that is shared is drawn with a line. And since we have 2 pairs of electrons shared right here, that's going to be 2 lines, which represents a double bond. Also, don't forget to draw your lone pairs of electrons around your oxygens. So that would be our final Lewis structure for sulfur trioxide. Let's go back to the beginning and do another example. So we're going to work through the Lewis structure for NOCl. And this time I'll show you what it looks like to actually draw it out step by step. So step 1 is find the total number of valence electrons. So we have a nitrogen, an oxygen, and a chlorine. We only have 1 of each, so we just need to know how many valence electrons they have. If we look up on the periodic table, nitrogen has 5, oxygen and chlorine has 7. So together, that gives us a total of 18 valence electrons. Step 2 is draw a skeleton structure. So I'm going to put my first atom in the middle and my other atoms on the outside of that. And I'm going to start with 2 shared electrons. So 2 shared here and 2 shared here. Step 3 is replace remaining electrons around the atoms starting on the outside. So I've already used 1, 2, 3, 4, and remember I only have 18, so that means I have 14 left that I need to put somewhere. So I'm going to start on the outside and work my way around, and remember not to give more than 8 to anyone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Since oxygen already has 8, chlorine already has 8, my last 2 are going to go to nitrogen. And our 4th step is to make sure all atoms have a complete octet. So let's check. These electrons belong to chlorine, these ones belong to oxygen, and these ones are shared with nitrogen. That gives us 2, 4, 6, 8 for chlorine, 2, 4, 6, 8 for oxygen, and 2, 4, 6 for nitrogen. Since nitrogen doesn't have its octet yet, we're going to move electrons around to form double or triple bonds. So let's just say oxygen, and we're going to take 2 of oxygen's electrons and move them so that they're shared with nitrogen. So here's what our final structure would look like. Nitrogen double bonded to oxygen, which has 2 lone pairs, single bonded to chlorine, which has 3 lone pairs, and we have that 1 lone pair left on nitrogen. You might ask if it matters that I chose oxygen to share. For right now, don't worry about that. Either one of those would have been a correct answer. You could have put the double bond here or there. One more really important thing you need to know is that hydrogen, remember, is an exception to the octet rule. Hydrogen does not need 8 electrons. Hydrogen only needs 2 in order to be happy. So you should never, ever, ever see a lone pair of electrons outside of a hydrogen. Hydrogen should never have more than 2. So hydrogen will always just have a bond. It will never have extra electrons on the outside.